This brings me to, after the first part, brings me to the next part of my talk, which is about language phylogeny from phonetic features. I'm basically going to talk a little bit about the previous works that we have been doing in creating different phylogenies with phonetic features, and I hope that you'd appreciate the effort here. Note the data that we have shown you. I have shown you a little earlier on Tibeto-Burman languages, which looked somewhat like this. And I told you that we could actually have two categories of languages here. As we can see, we can just give two abstract categories here, category 1 and category 2, because 2 is very different from the rest. So within category 1, we have the Borogar languages of Tao, Dao, Dao, Tu, etc. and Amrikarbi, which just is completely different from the other. So we categorize them, the Amrikarbi language, into another category. So we have marked them as 1 and 2. Now this can be used to create a matrix for different languages. And these kind of data can be used to make a matrix for given languages, showing the similarity and dissimilarity or similarity and differences between each pair of languages. For example, if we look into the Boro Dao and Dimasa Dao, we can see that more or less there is only one character difference or one sound difference between the two. Rest of it is all very similar to among the two languages. On the other hand, if you come to, let's say, Boro versus Kosrava now, if you look into that, then you will see that here voicing changes, the vowels change, there are more number of changes that occur. So as a result of that, the distance between these two languages are more than between Boro and Dimasa. And of course, Amrikarbi does not even come into count here because it is all the way too different. So this is what we can utilize for our hierarchical clustering, which will give us some sort of language tree in our analysis. So based on the similarity, in this particular study that I am showing you now, what we did is that we collected this data from about different languages for about 208 words. And if you know about this list, it is called a Swadesh list, which is supposed to have consist of all the basic words that are used in a particular language. However, there are many studies which are opposed to the idea also, because they consider that this is not the best list. Nevertheless, this is the best what we could get at that point of time, that we got this Swadesh list of 208 words, and then we got the phonetic transcriptions of these 208 words across, I think, about, if I remember it correctly, 18 different languages. And these 18 different languages, we calculated the similarity and dissimilarity among them. So based on similarity, this is what we get. When we for all the 208 words, when we calculated the similarity, then we found out that Atong and Kosrava are 38.61% similar. And then if you go Amrikarbi has a pretty low score here with the other Borogaro languages. But Borogaro languages more or less have very high numbers here. So this is now what I have talked to you about earlier, how we can convert our data from responses, some sort of textual responses, to numerical data. At this point of time, what we are doing is that we are converting the similarities and dissimilarities. We are giving some sort of numerical values for these differences, and we are hoping that we will be able to achieve certain type of hierarchical clustering using this. So now what we can do is that we can use them for, as I said, for the hierarchical cluster. And there are many different ways of creating this, these different hierarchical trees, which we'll discuss on day 3 of this course. And I am using that in this kind of cases. What I am doing is that I am using something called WPGMA, weighted pair group method of arithmetic averages. And so basically I'm looking at the average of each group, and then I'm comparing which it has the least kind of difference, and clubbing them together into one group. So I go into creating these kind of clusters. This is a clustering method. This WPGMA is basically a hierarchical agglomerative clustering, or HSE method, where the nearest two clusters which have the closest correspondences are combined into a new cluster, which is, let's say, the B and C are combined into a cluster BC. Then what we do is that we look into another cluster which may be most closely corresponding with this BC cluster by looking at the average of the B and C clusters. If you don't understand this, you don't worry about it now, because anyway we'll have some examples of it on day 3, probably in the second half, of how to arrive at that. Diagrammatically, this is what, thanks to Uri for this, we arrive at this. You can see that BC, they're clustered together because they are the closest, they have the highest kind of similarity. They are clustered into BC group, and then from DE you again have a cluster coming out, and because they are very are together, DE and F are very similar, they together form the DEF cluster, and so on and so forth. So we keep on creating these clusters until we have only a single cluster at the so it's a very much bottom up kind of approach. We are going from the lowest part and then clustering going up to the final terminating node. So then when we do that, what happens is that we get a cluster dendrogram like this. This is exactly from the data that I showed you a little earlier. This is what we have presented in 2012 in one conference. So now you can see that how closely it actually it matches our hypothesis. If you look at Karbi has two actually varieties, the Karbi spoken in the hills and the Amri Karbi, which is spoken a little bit about 30 kilometers away from IIT Guwahati, where you are now. So the Amri Karbi variety and Karbi both cluster together into one cluster, right? However, they are not part of this big cluster here, because all the languages in this big cluster are basically Boro-Garo languages. Remember what I showed you in the earlier slide, where that the Amri Karbi stayed out because it was not very lexically similar to the other, and that is basically captured now by the numbers that we have generated from comparing different phonetic representation or phonological representations of these different words. So here you can see that Atong Rava are very close together. This whole group, Borok, Kokborok and Dimasa, very closely connected. They have a lot of similarities among them. Garo and Tiwa are very closely related. And if you I remember in 2006 I was collecting data in the Tiwa areas, and most of the Tiwa residents there, they actually listen to the Garo programs in the radio. So